Hi everyone, welcome back to the next lecture in the Substitution and Elimination Reaction series. So we're going to start going over a little bit about what SN1 and SN2 represent and what they actually mean in terms of the abbreviations. And we'll also touch on eliminations in here before we start doing a deeper dive into all of the different aspects that can affect the substitution and elimination reactions that we discussed in the previous video, like solvent, nucleophile, or leaving groups. Before we get started with that, just a very quick reminder, you guys can head over to chemcomplete.com, and at our website you can get in touch with us for one-on-one tutoring directly from me. You can also go ahead and check out the walkthrough guides that we have available for $5 a piece. That helps to support the channel so we can keep bringing you free YouTube content. And we also have a free resource page that we are currently working and updating every week in order to provide you guys with high quality free resources. So go to chemcomplete.com and check that out. Now, what does SN1 and SN2 actually represent? So the S and the N are discussing, probably might be obvious to you, substitution reactions for the S, and the N stands for nucleophilic. So those are the two major portions there. Now the 1 and the 2 are referring to the types of kinetics that these substitution reactions are going to undergo. So when you talk about an SN1, you are talking about unimolecular kinetics. So that's what the 1 stands for. And this means that the SN1 reaction is only going to be dependent on one molecule. And that molecule is going to be the leaving group. So when you get ready to look at the kinetics here, if you remember what this looks like, you can say that the rate of a reaction is going to be equal to, and then you have, it's usually represented by a lowercase k, which is the rate constant. So we'll put that there. And then it's going to be the concentration of anything that would be participating in the reaction. And then it would be raised to a certain order. If you remember back to kinetics, you can have first order, second order, and you can talk about the order of the reaction overall, and then the order of each individual component. So in the unimolecular kinetics, we have the rate constant, and then it's going to be the product of the rate constant and the leaving group. So I'm just going to use R as a general alkyl molecule and then X as the leaving group. So the concentration of the leaving group is the only thing that's important in an SN1 reaction. The nucleophile does not play into what's called the rate limiting step. And so when we have unimolecular kinetics, it is only going to be determined by how fast the leaving group can depart. Now in terms of bimolecular kinetics, this is for the SN2. Bimolecular is going to mean two molecules, and so it will be a little bit different in where the rate is going to equal the rate constant. But for SN2, the nucleophile has to come in as the leaving group is leaving, so they have to work simultaneously. So it will be the concentration of some given leaving group on an alkyl substituent multiplied by the concentration of the nucleophile. And SN2 is going to rely on both of these factors, making it bimolecular. Now I have a note here, and it's important to pay attention to this. The 1 and 2 do not represent the number of steps to complete the reaction. And in fact, it is just the opposite. So when we have a bimolecular reaction with the SN2, it occurs in a concerted single-step mechanism. Okay, so it's all in one step. The R and the X here, as the leaving group leaves, the nucleophile is going to come in at the same time. This all occurs in one step, and then it provides you with the new nucleophile that has displaced or substituted the leaving group. And then you would have the leaving group out here, right, X minus in solution. So in an SN1, you, at the very minimum, have to have at least 2 steps. Usually there's up to 3 if you have a neutral nucleophile, and that's a bit beyond the scope of this lecture, but we will get into that later in this course. So we can essentially view this as we have Rx, and we're waiting for the leaving group to leave. That's going to create a cation somewhere on the alkyl chain. So that would be step 1. And then in step 2, the nucleophile would then rush in after the rate limiting step is over, and the nucleophile would attack the cation, and then we would finally end up with R nucleophile and X. So it looks, the final result looks very similar, and in fact it is similar to the SN2. However, it required more than one step here in the SN1. So again, don't get confused and think that 1 means 1 step and 2 means 2 steps. It's referring to the kinetics. The steps are actually the reverse of that. So SN2 will be in 1 step, and then the SN1 will be in 2 or more steps. Okay, now what about eliminations? Because we mentioned that in the previous outline lecture getting ready for this course. Eliminations, and we will be discussing these in much more detail later in the course. We're going to look at substitutions first. But eliminations follow the same premise. You're going to have, and I'll expand this a little bit more here, when you have the Rx, what we're really going to look at for an elimination is you have some leaving group X on a carbon, and then the adjacent carbon is going to have some hydrogen group on it. And when you have the nucleophile, nucleophiles are going to also be bases. And given certain conditions and setups, that nucleophile may end up acting more like a base and removing a hydrogen than it does as an actual nucleophile to come in and substitute. So it is possible to have a leaving group leave, and as that leaving group is leaving, a hydrogen is being abstracted by a nucleophile, which is really behaving as a base in that case. And the electrons in that adjacent hydrogen bond will come in and create a pi bond between the carbon that had the leaving group and the carbon that contained the adjacent hydrogen. And when we create a double bond, that would be an alkene. So when we have elimination reactions, we have a leaving group, we have a nucleophile which will behave as a base. So it's identical on paper to an SN2 or an E2. And then it's identical for an E1 and an SN1. You can't really tell the difference by just looking at the actual material that's written down there. You have to understand and realize when you've got certain situations that are going to lead to E2 versus SN2 and E1 versus SN1, right? So what you end up with is an alkene. Now, these reactions require 2 major components in case you haven't gathered that by this point. The first one is going to be an atom or grouping of atoms that we can have readily leave and depart into solution. So this is known as the leaving group. And that is essential. We have to have a leaving group in order to get these reactions to move forward. And then the second thing that we have to have is an incoming atom or grouping of atoms with a lone pair of electrons that will be available for bonding. So that is the nucleophile or base that we keep talking about. Sometimes these will be negatively charged, so you could have a situation like OH minus where you have negative charge like that, or it could be a situation where you have something like H2O. H2O does not have a negative charge. However, it still could technically act as a nucleophile or base because the oxygen has lone pairs of electrons, and that is all that's needed under the definition of a Lewis base in order to behave that way. So that pretty much wraps up the summary on SN1, SN2, and eliminations and looking at the difference between those and the kinetics. So in the next lecture, we will start to dive a little bit further into the actual aspects that are going to make up the substitution and predicting whether or not it's going to be SN1 or SN2. And we'll start by looking at leaving groups, then we'll move to nucleophiles, and then finally we will end up with solvents before tying them all together and looking at some examples of SN1 versus SN2. So again, one more time, head over to chemcomplete.com to check us out over there. Hopefully this lecture helped to outline some of what you needed to know to get started, and we will see everybody for the next lecture. Thank you for learning with us, and we will see you there.